Hello, my name is Corey Baird, a third year PhD student at the School of Public Policy. I am quite passionate about teaching statistical software, and so I am happy to be continuing this School of Public Policy data seminar series that we started last semester in the fall of 2021. This semester will follow a very similar format, so I just want to kind of cover those logistics for those of you who are not familiar or who are joining for the first time. All of the material that I create for the seminar series, and by material, I mainly mean code, will be hosted on this website, which I will provide on the Elms page. This website is actually just a public website as well, so actually it can just be found if you search Corey Baird and SPP Data Seminar, it should come actually up on Google. And you'll notice that there's two kind of main folders here. The 2021 fall material is actually just in this folder, and the material for this semester is here. Now, I have actually provided kind of the seminar goals as well as the seminar schedule right here. So it will be hosted, these sessions will be hosted January 28th, February 4th, and etc. And it will be starting from 10 a.m. Eastern. And the format will be more or less, I will record videos prior to the sessions. And I would really like you to watch those videos beforehand and try out some of the coding yourself so that when you come to the sessions, you're kind of already familiar with the concepts. And if you have questions, you can ask. Now, if you just click on this folder, you'll notice that there's two session notes. I like to split the sessions up into two parts just because they can be quite dense and a little bit um, yeah, hard to follow if you don't take a break. So we will be covering both of these modules, I call them, in the first week of this series. And so what I want you to do is to click on the first session, module one notes, and I want you to try to follow along with me. We are going to be covering Python for the first three sessions. So there'll be a total of six modules. Sorry if this is a bit confusing, but there's three sessions for Python. I'll go back to the main page and just show you there's three sessions for Python, which will consist of two modules each, and there'll be three sessions for R, which will consist of two modules each. And I'm more or less covering the exact same thing in both. I'm going to be covering how to import data, how to clean the data, and how to do some fun stuff like graphing, and potentially, if we have time, show you a little bit about machine learning and regression and all that good stuff. So I want you to, again, to click on the module one notes. And on the left side of your screen, I think it's great to have these notes. And then on the right side of the screen, I want you to run your Python code. Now, there's a number of ways you can run your Python code, but I highly recommend that you at least start off using Google's Colab software. The reason I recommend this is because it's just incredibly easy to use, and it's free, and it requires no installation. A lot of people start trying to learn a coding language like R or Python, and they get really frustrated because it's actually quite complicated to set up on your computer. But because we have the beauty of cloud, now we can access Jupyter Notebook, which is what we run Python in on Google. So if you just go to your drive, you go to more, you should be able to find this Google Collaboratory. If you don't see this, just search on Google and you should be able to find this. And you just click on it, and then that will launch a new notebook. Like I said before, we're running Python inside of this notebook. And there's also kind of an alternative that you could try out if you're a little bit more ambitious. You can run a more or less similar notebook that you're seeing on the right side. In fact, you can run this exact same notebook by just downloading the software called Anaconda. And I might go over this like later in the semester if people are having trouble downloading it onto their computer. But in the meantime, let's use Colab. So what are the basics of Colab? Well, to run a piece of code, you can either press Shift Return or this little play button here. And as you can see, I just pressed Shift Return, and while it was running the code, it was kind of, going around. And so that just means that it was working. If you're having problem with the code or something screws up, you can go to this runtime tab here and click restart runtime, and then that will restart your code, but I'm not going to show you why you would do that just yet. And then in this first module here, I just want to cover the basics of Python. What is it and what are data types? Now, you might be a bit freaked out by all of this information that I'm giving you, but I want you to know that if you are familiar with any other programming statistical language, Python is actually incredibly similar. So for our users and for Stata users, I think it's a pretty easy transition because a lot of the functions and a lot of the code is actually exactly the same or very similar. So for example, in Python, you can make comments by using that hashtag. This is a comment. If you run the comment, nothing will actually come out because the comment is actually not read by the code. And so there's also these print functions. And I actually want you to try to actually copy and paste this material into this notebook here. And so you can follow along and do it while I do it. So this here, I'm going to be running the print function. So again, for our users, you might be familiar with what this does. Basically, it just returns this information here. And again, as you can see, the comment was not returned. It's only returning this. Saving objects is also the exact same in Python and R. And so if you want to say, for example, save this object here, which I'm just naming SPP, what I'm going to do is I'm going to run this. And you don't see anything actually happening here because all I'm doing is just saving this object, and this object kind of exists out of sight. But if you type in the name of that object, it will return that. Now, one thing that's easy to kind of get tripped up by is that in order to get that to work, you have to make sure that this piece of code comes before this piece of code. If not, then it's not going to print. So let's create a new object called saved one, and just put my name, and then let's try to print off that saved one object. What you'll see here is now we have an error because that object was just never saved. Now, if we run it again and run it again, now you can see that object has been printed. So this is a bit tricky part about using these notebooks is you have to make sure that kind of the ordering is correct. Next, I kind of want to show you how to create a text box. So if you just press this text button here, you can actually more or less follow along with the way I created this notebook here. So now I'm just saving that. I'm running that cell and moving on, and now I can run my code. So there's more or less 3 or 4 different types of objects that I want to introduce you to. I promise that I will get to a point later in this introduction where we're actually going to be loading in data. I want to make sure that I show you information that is actually useful and not just incredibly boring, but these are kind of the basics that I really, really want to cover and I think are incredibly important for you to know. So let's go back here up to the string section. And in this, we are just saving the string object and then printing that string object off. So that's exactly what we were doing up here. These are technically what's called string objects. You can delete cells by this little button here. And then we can also see what type of object it is by using the type function. So we just, instead of print, right, we just use type. and we say inside, we pass in that string object, and it should tell you that indeed that object is a string. Okay, well, what are the other types of objects? But I guess before we get there, I wanted to cover one more thing, and that is overwriting. So strings can also, and objects in general, can be overwritten. So if I wanted to update my string equals, just say Python is not cool. Sorry, I have a bad sense of humor, but if I say Python is not cool, what you'll see is that string has now been changed to Python is not cool. Before it was Python is cool, and as you can see, the name is the exact same, but because it's been overwritten, the output is different, right? All right, so let's move on to integers and floats. These are just more or less numbers. It's just a really kind of a fancy way to say number, rather than the string. And so we can save this object. I'm just naming it my num, and I'm running that cell, and it will show that it's an int object. I'm going to do the same thing with a little bit more complicated of a number. I'm going to run it, and it's going to show that that number is a float. And if you type it in again, you'll notice that it's just printing off. Okay, so those are kind of the two most basic. Getting a little bit more complicated now, we're going to look at lists. So lists essentially are just, they can actually be or contain floats, integers, or strings, but they're just kind of like a collection of objects, as you can see here. So list, let's copy and paste that in, and let's just run it. I can just show you that if I saved it like this, nothing is going to come out. You'll notice that that is the same case for here, right? So some of you might be confused about, okay, did it work or not? Well, the first reason that it probably worked is that there's no error. If I tried to do this, there's going to be an error because I didn't make sure that everything was correct. If there's like a missing comma, again, we're going to get an error. If it worked, then you're not going to really see anything. And you can check whether it worked for sure by calling that object or printing that object again. And so we can see it work. And lists are very nice because there's really not like a limit how long they can be. They can be as long as you really want them, and they contain a lot of times information that's really helpful for us to manipulate our data. Now we can also put in not just strings, we can also put in numbers. So you're going to see here that both of these are actually lists, despite the fact that what they have inside is different, right? This is a string, this is a number, but both are lists. Okay, and the last thing I want to cover, I promise this is the last extremely boring thing. What I'll cover next is how to import data, which is actually more interesting because it gets us closer to actually using this. But we just need to cover indexing really quickly. Try to follow the number. And so indexing is essentially taking out pieces of that list. So in this example, I'm overwriting this number list here, and I'm putting back in strings. And let's run it first. Nothing comes out, so we know that it works. And I'm just going to put a number inside. What happens? Well, that actually prints off the first element of the list. Now, this is extremely confusing. Part of Python is that the numbering starts with a 0, not 1. In R, the numbering starts with 1. In Python, it's 0. If I were to type in 1, you're going to see that it prints off actually the second element of the list. And if I type in 2, it's going to print off the third element of the list, and so on and so forth. There's also ways to slice the list. So that just is a fancy way to say select more than one object within that list. And this is, again, pretty confusing. The first part selects where that slice starts, and the second part selects where that list ends, but it's not inclusive. So let's actually run it to see what I mean. So it starts at 0 and goes till, so it takes the 0 element, the 1 element, and then it does not take the second element. It stops before the second. So if I were to put 3, this means that it's taking the 0, 1, and the 2 elements, but not the 3. Okay, and you can also start it wherever you want, and you can stop it wherever you want. Okay. So it's a bit confusing, but I want you to play around with these numbers to get in a little bit of a better intuition. All right, finally, we're to something interesting. So this is what I really mainly want to teach you in these Python seminar series is how to use pandas. It's incredibly powerful, and it looks incredibly hard to use, but once you get a better intuition for it, it's actually not that bad. For our users, it's very similar to dplyr. So a lot of the functionality is exactly the same, although it's a bit it's a bit different. So before using the library, this is again similar to R. We need to actually import that library. So you might be familiar with the fact that in R you need to import the library before you start using the functions, and Pandas exactly the same way. So in order to import the Pandas library, you just always write this. So you say import pandas as PD. Now, what is PD? Well, PD just basically gives us access to all of the functions of pandas. So function name, and then a lot of times you can put something in that function. So PD function name basically gives us the access to that library. And I promise that I will kind of show you what that means. This is kind of a bit hard to understand, I think, if you're not familiar with Python. So just bear with me for a second. The file that I'm going to use to import the data is actually on my GitHub, and it is just a CSV file. So this is like the long URL name, and then this is the name of the file. So if you had this file in the same folder as your code, all you would have to do is actually just put in vote.csv. If it was in a subfolder, you would have to add the subfolder. But this is pretty nice because all you have to do is just copy this URL, and then we can download it with the import function of pandas. So what is that import function? So like I said before, whenever we want to use any pandas function, we type in PD and then we type in dot and then the name of the function. So in this case, as you can see here, it's a CSV file. If it was not a CSV file, then obviously, well, not obviously, but I think to most people, it's pretty obvious that this wouldn't work. So it's what's not obvious is what the name of the other function would be. So this is just, you kind of have to memorize it. There's a function called read Excel, and I'll introduce you to the most useful ones. But if you try running this, it's not going to work because it's not the same format. So this URL, I just don't want to confuse you here. It's just a string object like we were using before. And the reason I do that is just to make the code a little bit more readable. So once we have that string object saved, we're just basically putting this inside the read CSV function. Okay. Now what happens? Voila, it worked. It read the data, but it's just kind of sitting there, right? It doesn't look like it's actually been saved. And that's because, like the other objects up here, in order to save an object, you need to set it equal to something, and you also need to title it. So these titles, as you might have noticed, you can just name it whatever, and it set it equal to. What you can't do is put any spaces, and that's why I use these little underscores a lot. So let's name this data DF, which is short for data frame. So now we'll run it, and it looks like something happened, but what? Well, we can look whether it worked by just typing in the name of that object, and look, it looks like it worked, and it looks like it's exactly the same as before we saved it. And so now you can also use the type function to try to see what kind of object it is, and it will tell you that it's a pandas data frame, more or less. Now we can get into like exploring the data a little bit more. So we can show kind of the very basics. So the first thing we can do is show info. So it's just the name of our data frame dot info. We can also save multiple data frames with different names. So these data frames would actually be more or less equivalent, but we actually can type in both of them because both of them now are saved in our system. So if I wanted to see info for each data frame, I would just type in the name of the data frame and info. And as many of you might have noticed, these programming languages are quite picky. And what I mean by that is if you make any type of small mistake in the name, it's not going to work, right? So just make sure that you're being really careful with the names. What are some of the other things we can do? We can show the first couple rows, and that will be using the head function. Inside the function, if you just put a different number, you'll see that a different number of rows will be shown. Okay, so that's the head function, which is exactly the same as in R. There's the tail function. It's the exact same concept. You type in the number. The default is just showing 5. So if you don't type in anything, it's just going to show 5. So that's the head, the tail, and the information function, the info function. We can also get descriptive statistics. So we can get df.describe, and it'll show us the count, the mean standard deviation. And we can also get the names of our columns. So this is actually slightly different than R. R is names, and in Python it's columns. So you just type in the name of the data frame, dot columns. Let's see if we can get it to work for this one as well. And sure enough, it works, and it's exactly the same. Okay. If you want to not have that code be shown, you can just comment it out and run it, and we'll get rid of it. Okay, and now I kind of want to show you how to use those like list functions. Just want to make clear that this is the manipulating list part. So as you can see here, this actually looks pretty familiar, right? This is a list. So if we want to save this information as an object, all we have to do is type in the name of that object we want to save. So columns, we can do whatever. We can do calls. And if we type that in and print that off, it's going to print that off. We can slice it exactly like we were doing before. So if we want to take the first 3 elements, we would type in that. Excuse me, first 3 elements would be this. If we want to take the second to third element, we would type in this. Now, some people who are copying and pasting this over might be a little confused that it's not working. Why? Because we actually have not saved any object called columns. What I saved is one called calls. You just got to make sure that the naming is correct. Okay. And again, remember that the indexing starts at 0. The convenient thing about indexing is you can also take it, -2 would be the second to last element. So again, got to make sure that the names line up. We take the last 2 elements. Okay, so the last thing I want to cover here today is how to select a column. And we're going to get into this more next week, but I just wanted to introduce the concept to get you used to it. So you can select a column by 2 different methods. You can type in the name of the data frame, brackets, and then the name of the column that you want. And it looks like it worked. I want you to try to, well, let's see this here. These are the name of our columns, so you can type in any of these names and it should work. And the other way to select a column is just to type period instead of these brackets. So it's a little bit more of a quick version of this, but slightly different. And then, yeah, that more or less covers what I wanted to show you today. And this very like last part, I just want to show you some kind of bonus material about why Python is incredibly useful and powerful because we can download data. I mean, really one of the strongest things about Python is you can download data very seamlessly from various websites. So this data set here, which I'll actually cover in the next data set, is just on this web page. And this is just a screenshot from the web page. And there's just this Excel file that I noticed here. And so I just right clicked on the file and I copied that link address, which gives me this. And what I did with that is I saved it as an object. And then I put it in this read Excel function. And then I put the URL in that Excel function, and then I specified a sheet name. This is the second sheet. Remember that the numbering starts at 0, so the 0 sheet would be the first sheet. The first sheet would be the second. And so if we ran that, you will see that we have this data frame. And it didn't save; it just spit it out. So let's save it. And it looked like it worked. So let's see info. And it looks like, wow, we have a lot of columns. We can subset that like that. We can show the first 4 columns. We can also do that. We can also do this with HTML data, like Wikipedia pages. So again, these are all functions in the pandas library. I'm typing that PD. There's also a pandas function called read HTML, and that is just an incredibly easy way to just scrape websites. This is just a Wikipedia page of the largest cities, and you'll see that I get this information on the largest city in the world. Anyways, I'll see you in the next module where we'll be covering more data manipulation and reviewing what we covered today.